Here we have a very simple tremolo circuit, and we're using a Vactrol. This one is homemade. You can see that I have two LEDs blinking on and off inside of this straw, which I got from Dunkin' Donuts. And the LEDs are responding to each half cycle of the oscillating square wave. That's why they're on and off and not fluctuating smoothly in between. You can see that on the other side we have this photoresistor, and that goes to this op amp, and there is a current, a oscillating current from another oscillator coming into here, and it's being amplified via the amount of resistivity of the photoresistor depending on how much light it is getting. And right now I have it so that you can see through it, and it works relatively well. We also have the oscillator circuit up here, which is creating the wave, the square wave, that is driving these LEDs. And that wave then goes into this right side of the op amp where it is passed on to the LEDs. So now we can see this is the original wave. The wave is being generated by this function generator within the oscilloscope, and it's a very straightforward sine wave. Now let's see what happens if we look at the wave that's coming, that's being amplitude modulated. So you can see that it's going up and down in an exact synchronicity between the screen and the lights right there. And so there's this variation like that. So putting them together, we can see, we can see the original wave, and because there is an inverting amplifier on the right side here, which is passing the signal here, and there's also an inverting amplifier over here, we get an inverted wave. Actually, it's the signal inverting amplifier on the left side, I believe, that's causing the inversion. But anyway, that is this circuit. We can adjust the speed of the tremolo via adding a potentiometer to this oscillator right here, but this is not shown. And in any case, this is the circuit. I could cover this up if I want to. If I cover this with my hand, you can see that the waves actually fluctuate a whole lot more. So that's something to definitely keep in mind. And that is about it. Just make sure that you are using relatively bright LEDs, because their brightness usually is less than sunlight anyway. So if you're testing the photoresistor's value of sunlight, you're not going to get the same results. And because of that, this resistor right here in the inverting op amp for the actual oscillation that we're seeing here on the first channel, this one had to be reduced down from a mega ohm, which seemed appropriate at the time, to, I believe this is 22 kilo ohms, and that seemed to be fitting here. I could also double it, or I could add a potentiometer, but there's the basic idea. Okay, so that is the circuit. Thank you for watching, and I hope you learned something. I learned something. Everyone learned something.